Okay, welcome back. A couple more topics for this week. So returning to our slides, we had talked about this a little bit, but here we have a section on different data types. And if you can see on the slide, we've got 6 different, these are simple data types in Java. So let's just take a look at them. Before we look at the details, a data type, and these are actually numeric data types. The data types define the amount of memory used to store the number, the kind of number being stored, and the precision of the number being stored. So let's take a look. The first one is a byte. That is an 8 bits, so it takes 8 bits of memory. 8 bits is known as 1 byte. The range is -2 to the 7th to 2 to the 7th minus 1. And that refers to the 8 bits that are used in the representation. So that's -128 to 127. A short is a 16-bit data type, and by signed, what does that mean? It means we can store both negative and positive numbers. For short 16 bits, -32,768, that happens to be 2 to the 15th, or -2 to the 15th, to 32,767. Moving right along, we have integer. I know these are all integers per se. The integer data type has a wider range than the first two, byte and short. It's 32 bits, -2 to the 31st to 2 to the 31st minus 1. So what is this big number? This is 2,147,483,647. It's a big number, and it's useful for a wide variety of computing needs. But if you need an even bigger number, and again it's an integer, no decimal point, you've got a long. A long is 64 bits. Again, a signed number. You see it right here. Much more precision, so I'm not going to read this big number here, but you can see it's significantly, and because it's more than twice the size, the fact that it's twice the bits does not necessarily mean it's twice the range. It's much more than twice the range. So these first four are integer data types: 8, 16, 32, 64. By integer data types, we mean their numbers without a decimal point. Our two simple floating point type numbers, and we've talked about these just a little bit. Those are the simple types float and double. These are 32 bits and 64 bits respectively, and the format used is what's known as IEEE 754. IEEE is the Institute of Electrical and Electronic Engineers, and 754, that's actually a technical committee. That's a specification for floating point numbers. And you can see the range of the double. You just get significantly more precision with the double, more significant digits than you do with the float. Both of these you can use for representing both negative and positive numbers. So these are the numerical data types. You need to pay attention to them, and when you add data to your program, you need to ask yourself, what kind of a number do I want to represent? And based on that answer, you select the appropriate simple type. I'm going to fast forward ahead a little bit. I want to talk a little bit about, well, let me go back. So the numeric operators, these are things you probably know already. Very straightforward. We'll just spend a moment on them. Addition, plus sign, we all know this. Subtraction minus sign, multiplication is a star, division is a forward slash. Here's one you might not know. This is the remainder operator. So let's just take a look here. What do we got? We've got, and it's a percent sign, a 20% sign 3. So 20 divided by 3, what is the remainder? So how many times does 3 evenly go into 20? It goes 6 times, that's 18, with a remainder of 2. So this might, while the first 4 are intuitive, and you've been doing it your whole life, this one, and you've been doing remainders, division and remainders your whole life as well. Here is a remainder operator. This might not be as intuitive. Now, you need to pay attention to this. Division with computers, you need to pay attention to the data types. So let's talk for just a minute about something called integer division. When I divide 2 integers, I get an integer result. Let me say that again. When I divide 2 integers, I get an integer result. Let's look at this first example here. I've got 5 divided by 2. Both of them are integers. 5 divided by 2, how many times does 2 evenly go into 5? It goes in twice. The remainder is truncated. It's thrown away. So if you were to write this line of code like this in your program, 5 divided by 2, the result you will get would be 2. Now, suppose you wanted, true division, floating point division. You'd have to use floating point numbers or floating point variables. In general, if either of the arguments, either of your operands, are a floating point, either the numerator or the denominator are floating point numbers, you will get a floating point result. So in this case, we go 5.0, this is the floating point number, divided by 2, the result you get is 2.5, and that's more intuitive. That's how you would do it if you sat down, with a pen and paper and tried to do it that way. So just be aware of this. Think about what you're doing. If you're getting results that seem, just completely non-intuitive to you, and it's, pretty simple math you can do yourself, and it looks like the computer's doing it incorrectly. Well, the computer probably isn't doing it incorrectly. You probably just don't have the right data type. So just be aware here. When you divide 2 integers, you get an integer result. For example, let's do a quick example. You see here 5 divided by 2 yields an integer 3. What would the result be with 7 divided by 2? 5 divided by 2 yields an integer 2. Sorry about that. I was thinking about our example, and I've given the answer away already. What is 7 divided by 2? Integer division. The answer would be 3, of course. How many times does 2 evenly go into 7? It goes in 3 times. So just be careful with that. Okay, I'm going to fast forward just a little bit to number 26, slide 26 in our deck. In your homework this week, which I'll talk about momentarily, you're going to need to do some exponentiation. You'll have to do some operations with exponents. I've got an example program out on Blackboard for you, and I think it's pretty self-explanatory, and most of this is pretty straightforward if you have some examples to work with. But let's just take a look here. So to do exponentiation or operations with exponents, we've got a library function in Java, so we're going to use the math library and we're going to use the POW for power method. The way we do that is we just type math.pow and we give it an argument. The first argument is the base, if you will, and the second argument is the exponent. So this is saying give me 2 raised to the third power. Math.pow 2 raised to the third power. The result of this operation is 2 to the 3 is 8, as you can see here. You can do it with fractions as well. Give me 4 raised to the 1/2 power. What is the 1/2 power? The 1/2 is like taking the square root of something. So what is the square root of 4? That's just 2. You are not limited to an integer as the base. You can have 2.5 squared. Your result are 2.5 raised to the second power. That's 6.25. You can also have negative exponents. Here we have math.pow. 2.5 is the base, minus 2 is the exponent. What is that like? That's like 1 over 2.5 squared is another way to look at that. Bottom line is 2.5 raised to the minus 2 power. Your result is 0.16. Make sure you understand this. You will need to do this in your homework this week. And again, I do have an exercise for you out on Blackboard. Let's take a look before we wrap up for this week. Wrap up with the videos for week 2. Let's look at one more example program in the slides. That's slide 34 here. So here's a program for converting temperature. We're going to go, we want to write a program that converts Fahrenheit to Celsius using this formula, which you might not have it at the tip of your tongue. Maybe you do, but you've probably known this formula your whole life as well. Celsius equals 5/9 Fahrenheit minus 32. So you'll need to write code. So what do we want here? Let's ask ourselves the question here. What do we want here? Do we want an integer division here? We probably don't, right? So when we write code, we probably want to use floating point numbers. And remember what we said earlier, that at least one of them is a floating point number. The result will be floating point. So you'll need to write code that looks something like this. Celsius equals 5.0 divided by 9 times Fahrenheit minus 32. Let's go ahead and look at an example. I pulled it up earlier. There it is. This again, you can get this example by clicking on the slides here, and this is something your author has provided. Here's the code. So note that it uses a scanner for input. Here's our class. Our class is named Fahrenheit to Celsius. That means this code needs to live in a file called Fahrenheit to Celsius.java. You can see that right there. Let's see, here's our main method. We create a scanner, the name of a scanner object, its identifier, its name is input. System.in means we want to read from the console. Here we're going to prompt the user, enter a number and enter a degree in Fahrenheit. I might have said enter a number in degrees in Fahrenheit, or enter a number in degrees Fahrenheit. And here we're going to read that, and we're going to read it into a double. A double, so here's another variable in the program. Its name, the identifier for that variable, or its name is Fahrenheit. Its type is double, and here's where we get its value from, input.nextDouble. Where does that come from? It's going to come from the user at the keyboard. Here's the actual code right here for converting Fahrenheit to Celsius. And here's another variable, double Celsius equals, and we're actually going to declare the variable and compute its value all in one line of code. So we're saying we have a variable named Celsius, its type is double, and here's how I'm going to compute it. 5.0 divided by 9, so this will be a floating point result, times Fahrenheit minus 32. Remember where Fahrenheit came from? Came from up here where I read it using this scanner. And this very last line of code in the program, we're just going to print the result. The way these print line statements works, just a quick review, system.out.println, everything in between the double quotes here, that's just a string literal, so whatever is in there will be printed to the display. The plus sign is a concatenation operator, so here we're going to add to this string literal Fahrenheit, and here we're going to enter, we're going to print the value in the program Fahrenheit. Then I'm going to concatenate the string is, and here I'm going to print my result. And if that's a little confusing, I think it'll be clear if you just look at the example. If you look down the example here, here's where I ran it. I ran this earlier. I entered in 32, enter a degree in Fahrenheit 32. This is the output of the program right here. Fahrenheit 32 is 0.0 Celsius. Let's go ahead and do a different example. I'll enter 212. We'll compile it and run it. It's thinking about it. And what do we expect the answer to be? Here we go. So Fahrenheit 212 is 100 degrees Celsius. Again, you can do this yourself. Just click on this link here. So it works pretty well, and it's a good way to see what's going on. So there's other slides out on Blackboard for you. I do recommend you go through them. You can see there's quite a few. It's basic stuff, but it's important. You know, it's important. Nothing terribly complex, but there can be kind of a lot of material. So take your time and go through it. Also, your reading assignment, also out on Blackboard, is to read Chapter 2 as well. Now, your programming homework. So here you go. Your programming homework is going to be to write a program. There it is. And this is out on Blackboard for you. You're going to write a program for calculating the future value of money. So this is a fairly standard program. The future value of money, or future investment value, equals the investment amount, that is the present value, and here is the formula. This is just a standard formula from finance. It's 1 plus the monthly interest rate raised to the number of years times 12. So this, in this particular formula, we're compounding monthly. So again, it's 1 plus monthly interest rate raised to the power number of years times 12. For example, if you enter 1,000, annual interest rate of 3.25, number of years is 1. This is about what you get. You get 1,032, about $1,033 after 1 year. Here is some more sample. Here's some sample data, and this is just some sample output. Your program should do something like this. It doesn't have to be exactly like this, but this is just to give you an idea. For using this exponentiation, I put a program out on Blackboard for you to look at. It's called math.pow, or actually there's a program called POW. You'll use this math.pow method. If you click this link, it just takes you to the official Java documentation for math.pound. Now, what should your program should look something like this. So I've written the program and compiled it. Let me give it a name. So let's see. The name of the program is Homework 2. Here's the Java source file. I won't show you that. That's your homework. That's your job this week. And here after I compile it, I get this class file. So I'll clear the screen again. Let's run it. Java Homework 2. Okay, enter the investment amount. Let's enter, we'll do something. We'll enter a simple one first. Let's enter 1,000. Okay, enter the annual interest rate. We'll say we get 6%. Enter number of years as an integer, for example, 5. All right, we'll do 5. So what have we got here? We have $1,000 is our investment amount. The annual interest rate is 6%, and the number of years is 5. Now remember, the requirements of your program is you want to compound this monthly, so you're going to have to divide 6 divided by 12, which I think you can figure that out, and that'll be what you actually use in your calculations. Let's go ahead and run the program. And what have we made after 5 years? Oh, we're doing okay. We've made our $1,000 is worth $1,348.85. Let's do one more. All right, homework 2. Let's do $10,000. We'll do 4%, maybe a bit more realistic. 6. If you get 6 every year, you're doing pretty good. Let's see. We'll enter and we'll save for 10 years. What do we get? So what does this say? We're still doing pretty good. We started with $10,000. Annual interest rate is 4. Now remember, the requirements of the program are monthly. I'd like you to do the monthly interest rate. So you'll have to divide this by 12. Number of years as an integer, and this, for example, 5, but we put in 10. So what does this say? This says that after 10 years, our $10,000 at 4% compounded monthly, we've $14,908.32. So you can see we've made $4,908.32. So we're doing okay. All right then, all this material is out on Blackboard. I'll also post in Blackboard. There'll be a place, a discussion group for you to ask questions. You're always free to email me, to contact me through the week. I do encourage you to work together. I encourage you to work with a partner on this programming assignment, and actually all of your future assignments. You will learn from each other in this type of work, and we all have different levels of experience, different backgrounds. You definitely will learn from each other working together, so it's a good thing. Okay, that's all. Have a great week. Bring this homework to class next week, and be prepared. I'll come around and you can run it for me, and we can talk about if you have any issues, any questions. We'll just work them out together. Okay, that's it for now. Have a great week. See you next week.